Welcome to Speaking of Stones, where we uncover the world's most fascinating gemstones. I am Penty, and it is my distinct pleasure to guide you through these subterranean wonders, these crystalline marvels forged in the Earth's fiery heart. Each stone tells a story, a narrative of immense pressures, of slow, deliberate crystallization, of elements combining in ways that can only be described as miraculous. Our planet, a vibrant, dynamic entity, is a master artisan, and its creations, these gemstones, are its most enduring masterpieces, holding within them the secrets of geological time. Today we're diving into the realm of blue gemstones, exploring the rarest and most captivating ones. The color blue, so often associated with serenity, with the vastness of the sky and the unfathomable depths of the ocean, holds a particular allure. In the world of minerals, true, vibrant blue is a mark of exceptional rarity, a chromatic signature that speaks of unique chemical compositions and formative conditions. We shall embark on an expedition to find those specimens that not only dazzle the eye, but also whisper tales of their extraordinary origins, their journey from profound darkness into the light of human admiration. Our journey will take us across continents, delving into the geological narratives of 5 truly exceptional blue gems. We will marvel at their spectral beauty, understand the precise conditions that grant them their coveted color, and appreciate why they are treasured, not just for their aesthetic appeal, but for their profound scarcity. Prepare to witness nature's artistry at its most refined. As we unveil these cerulean treasures, each a tiny fragment of our planet's immense and beautiful story, now brought into the light for us to behold. Our first subject is a legend in its own right, a gemstone whose name alone evokes images of unparalleled luxury and breathtaking rarity, the blue diamond. These are not merely diamonds tinged with blue, but stones that possess a depth and intensity of color that seems to capture the very essence of the ocean's abyss or the twilight sky. Their formation is a saga of immense geological drama, occurring far deeper within the earth than most other diamonds, often originating in the lower mantle, a realm of unimaginable pressure and heat, sometimes more than 660 kilometers beneath our feet. The unique blue coloration, a deep, mesmerizing hue, is not derived from common elements like nitrogen, which often colors diamonds yellow, or from structural anomalies alone. Instead, it is the presence of minute, almost ethereal traces of the element boron, captured within the diamond's carbon lattice during its formation, that acts as the chromophore. This boron, a relatively light element, becomes incorporated under such extreme conditions, altering the way the diamond absorbs and reflects light, bestowing upon it this coveted and incredibly rare blue. The journey of these blue marvels to the Earth's surface is equally fraught with peril and improbability. They are typically brought upward by violent, deep-source volcanic eruptions, the kind that form kimberlite and lamproite pipes. These eruptions must be rapid enough to transport the diamonds from the mantle to the surface without them transforming into graphite or being otherwise destroyed by the changing conditions. It is a geological lottery, and blue diamonds are amongst the rarest of prizes, a fleeting glimpse into the profound processes occurring within our planet's hidden depths. Consider the sheer improbability. For every million carats of diamonds mined, only a tiny fraction will exhibit any discernible blue color, and of those, only an even smaller percentage will possess the saturation and clarity that classify them as true gem-quality blue diamonds. This makes them astronomically rarer than their colorless counterparts, placing them in an elite category of natural wonders. The Hope Diamond, perhaps the most famous example, is a testament to their allure and their almost mythical status, carrying with it centuries of history and legend. The intensity of their blue can vary from a pale, almost ethereal sky blue to a rich, deep, oceanic sapphire-like hue. Each shade tells a slightly different story of its boron concentration and its specific journey through the earth. Gemologists and collectors prize these stones not only for their beauty, but for this inherent narrative of extreme origin. The very light that passes through a blue diamond has interacted with atoms forged in the deepest accessible parts of our world, a tangible link to the planet's ancient fiery heart. Furthermore, blue diamonds often exhibit a unique phosphorescence. After exposure to ultraviolet light, some of these stones will glow with a fiery red or orange hue for a short period in the dark. This fascinating property, linked to the boron and nitrogen impurities, adds another layer of mystique to these already enigmatic gems. It's as if the stone retains a memory of the energy it has absorbed, releasing it slowly, a silent, colorful whisper of its atomic structure. The cutting and polishing of a blue diamond is an art form in itself, undertaken with immense care and trepidation. Given their extreme value, every decision, every facet is critical. The lapidary must work to maximize not only the carat weight, but, crucially, the expression of its rare color. The orientation of the crystal, the proportions of the cut, all play a vital role in how the light will dance within the stone, bringing its blue heart to life for the observer. These gems are more than just minerals. They are geological emissaries from a world far beneath our own. Their presence on the surface is a result of a chain of violent, powerful, and incredibly infrequent events. Holding a blue diamond is akin to holding a fragment of the Earth's deep mantle, a piece of primordial history solidified and brought into the light. It is a profound connection to the raw power and exquisite artistry of our planet. Their unique properties extend to their electrical conductivity as well. Unlike most other diamonds, which are electrical insulators, blue diamonds are semiconductors due to the boron impurity. This unusual characteristic further distinguishes them within the diamond family and has even led to some scientific interest beyond their gemological value, highlighting the multifaceted nature of these extraordinary stones. They are, in essence, natural anomalies of exquisite beauty. So, as we contemplate the blue diamond, we are looking at a confluence of extreme conditions, rare elemental inclusions, and a violent ascent. It is a masterpiece of geological chance, a symbol of enduring beauty forged in the planet's deepest, most inaccessible furnaces. Each blue diamond is a miniature chronicle of Earth's immense power and its capacity to create objects of breathtaking rarity and allure, a true treasure from the depths. Our next gemstone, grandidierite, transports us to the island of Madagascar, a biodiversity hotspot that also happens to be a treasure trove of rare minerals. This elusive gem, with its characteristic bluish-green to greenish-blue hue, is one of the rarest minerals on Earth. Its discovery is relatively recent in gemological terms, first described in 1902 by Alfred Lacroix, a French mineralogist who named it in honor of the French explorer and naturalist Alfred Grandidier, a man who extensively studied the natural history of this very island. Grandidierite's rarity cannot be overstated. Gem-quality crystals, those transparent enough and large enough to be faceted, are exceptionally scarce. For many years, the only known source was a small pegmatite outcrop in the south of Madagascar, near the cliff of Andrahomana. The conditions required for its formation, a specific recipe of magnesium, aluminium, boron, silicon, and oxygen crystallizing in a particular environment, are met so infrequently that finding even small opaque specimens is a noteworthy event. The color of grandidierite is one of its most captivating features. It typically exhibits strong pleochroism, meaning it can show different colors when viewed from different angles. Often these are shades of dark blue, greenish blue, and a near colorless or pale yellow. This trichroism adds a dynamic quality to the stone, a subtle shimmer and shift of hue as it moves in the light, making it a fascinating subject for both gemologists and collectors who appreciate such optical complexities. The challenge in acquiring gem-quality grandidierite lies not only in its sparse distribution, but also in the nature of the crystals themselves. They are often heavily included, fractured, or simply too small to yield a significant faceted stone. Therefore, a clean, transparent grandidierite of even a single carat is considered a major prize, a testament to the tenacity of the miners and the sheer luck involved in unearthing such a specimen from its ancient granitic or pegmatitic birthplace. While Madagascar remains the primary source, particularly for the finer gem material, traces of grandidierite have been found in a few other locations worldwide, including Sri Lanka, Namibia, and even Antarctica. However, these occurrences are typically of mineralogical interest rather than yielding significant quantities of facet-grade stones. The Malagasy deposits therefore hold a special significance, guarding the world's most coveted examples of this teal-hued marvel. The geological environment where grandidierite forms is often associated with rocks that have undergone high-temperature, low-pressure metamorphism or have crystallized from boron-rich granitic pegmatites. These are complex geological settings where a precise sequence of events and a specific chemical brew must coincide. The slightest variation and another, more common mineral might form instead. This specificity is the very essence of its rarity. Imagine the thrill of the prospector sifting through the earth, hoping for that telltale glint of bluish-green. The discovery of a new pocket of grandidierite would be an event of significant excitement, a rare unlocking of a mineral treasure that has lain hidden for potentially millions of years. Each crystal, whether destined for a museum collection or a unique piece of jewelry, carries with it the story of its remote and specific origin. The hardness of grandidierite, typically around 7 to 7.5 on the Mohs scale, makes it durable enough for use in jewelry, though its extreme rarity means such pieces are few and far between, usually custom-made for discerning collectors. When one does encounter a faceted grandidierite, its beauty is undeniable. A soft yet vibrant glow that seems to capture the tranquil hues of a tropical lagoon, a unique chromatic signature in the vast spectrum of gemstones. The search for grandidierite continues, driven by its beauty, its scarcity, and the scientific interest it holds. Each new find adds a small piece to the puzzle of its formation and distribution, helping us understand more about the complex geological processes that shape our planet and create these remarkable concentrations of beauty. It is a quiet pursuit, often in remote and challenging terrains, for a gem that whispers of ancient landscapes. Thus, grandidierite stands as a symbol of the Earth's subtle artistry, a mineral masterpiece painted in delicate shades of blue and green. Its rarity is a direct consequence of the highly specific conditions required for its birth, making each specimen a precious fragment of a geological moment, a beautiful enigma from the heart of Madagascar and beyond, cherished by those who appreciate the truly exceptional. Chapter 3. Benitoite, California's dazzling blue star. We now turn our attention to a gemstone of striking brilliance and a uniquely American heritage, benitoite. This captivating blue gem has the singular distinction of being the official state gemstone of California, a title it rightly deserves given its beauty and its almost exclusive occurrence within the Golden State. Its story is intertwined with a specific remote locality, the Dallas Gem Mine in San Benito County, after which it is named. Benitoite was first discovered in 1907 by a prospector named James M. Couch, who initially mistook the vibrant blue crystals for sapphires. However, their unique crystal form and properties soon puzzled mineralogists. It was Dr. George Louderback, a geology professor from the University of California, Berkeley, who correctly identified it as a new mineral species, a barium-titanium silicate, a composition previously unknown to science. This discovery added a new brilliant blue to the palette of known gemstones. The most remarkable characteristic of benitoite, beyond its intense sapphire-like blue color, is its exceptionally high dispersion, even greater than that of diamond. This property means that as white light passes through the faceted gem, it is split into its spectral colors, creating dazzling flashes of fire. Under magnification, or even sometimes to the naked eye in well-cut stones, these vibrant flashes of red and green can be seen playing within the blue body of the gem, a truly spectacular display. Benitoite crystals themselves are objects of geometric beauty, typically forming as flattened triangular or tabular crystals with sharp edges and a distinctive hexagonal outline when viewed from the top. They often occur in a matrix of white natural light, creating a striking contrast between the vivid blue crystals and their snowy host rock. These matrix specimens are highly prized by mineral collectors, showcasing the gem in its natural geological context. The historical significance of benitoite is primarily tied to its rarity and its unique discovery. For many years, the Dallas Gem Mine was the world's only known source of gem-quality benitoite. While minute occurrences have been reported elsewhere, including Arkansas and Japan, none have produced crystals of the size, quality, or quantity found in California. This makes benitoite a true Californian treasure, a geological anomaly concentrated in one small corner of the world. Famous examples of benitoite are perhaps less about individual, named stones of immense size, as its rarity often precludes the formation of very large, flawless crystals, and more about the collective appreciation for its unique properties. The largest known faceted benitoite is just under 8 carats, a significant gem given the typical size of crystals found. Museums like the Smithsonian often house fine examples, showcasing its brilliance and color to a wider audience. The conditions for benitoite's formation are quite specific, typically found in hydrothermally altered serpentinite. It crystallized from low-temperature, high-pressure hydrothermal fluids rich in barium and titanium, which infiltrated fractures in the serpentinite rock. This specific geochemical environment is not commonly found, which explains the mineral's extreme rarity on a global scale. The San Benito County deposit is a geological freak of nature. One of the most intriguing aspects of benitoite is its strong blue fluorescence under shortwave ultraviolet light. When exposed to this light, the crystals glow with an intense, brilliant sky blue, sometimes appearing almost white. This property is often used as a diagnostic tool to identify benitoite and adds another layer of fascination to this already captivating mineral. It's as if the stone has an inner light waiting to be revealed. The mining of benitoite has always been a challenging and often sporadic affair, given the remote location and the limited nature of the deposit. The Dallas Gem Mine has seen periods of activity and dormancy over the decades. Collectors and enthusiasts often make pilgrimages to the area, hoping to find their own small piece of this Californian blue star, sifting through the mine tailings with a sense of adventure and discovery. In essence, benitoite is a gemstone that combines a vivid, beautiful blue with exceptional fire and a fascinating geological origin story. Its rarity, tied to a single primary locality, and its status as California's state gem, lend it a unique cachet. It is a testament to the fact that sometimes the most extraordinary natural treasures can be found in the most unexpected of places, waiting for a keen eye to uncover their brilliance. Chapter 4, Heremegevite, the crystalline rarity from deserts and mountains. Our exploration now leads us to Heremegevite, a gemstone so rare that many seasoned gem enthusiasts may never encounter a faceted example. Pronounced Yeremeyevite, this aluminum borate mineral was first discovered in 1883 in the Adunchilon Mountains in Siberia by the Russian mineralogist Pavel Vladimirovich Eremeev, after whom it is named. For nearly a century, it remained an obscure mineralogical curiosity. The initial finds in Siberia were small, often pale blue or colorless prismatic crystals. While intriguing to mineralogists, they were generally not of a quality or size to excite the gem world. It wasn't until the discovery of new deposits, most notably in Namibia, in the Erongo Mountains during the 1970s, and later in Myanmar and Tajikistan, that larger, more richly colored and face-table Heremegevite crystals began to emerge, albeit still in incredibly limited quantities. The color range of Heremegevite is typically from colorless to pale yellow and, most prized, a delicate sky blue to a more saturated cornflower blue. Some rare specimens can even exhibit a violetish tinge. The blue varieties, in particular, are highly sought after. Like many rare gems, its beauty is subtle and refined, appreciated by connoisseurs who understand the profound scarcity behind its delicate hues. Notable uses in jewelry are, by virtue of its extreme rarity, exceedingly uncommon. When Heremegevite is faceted, it is usually for specialist collectors or high-end, bespoke jewelry pieces destined for those who desire the truly unique. The stones are typically small, with faceted gems over 1 carat being exceptional, and those exceeding several carats are world-class rarities. Its hardness, around 6.5 to 7.5 on the Mohs scale, is adequate for careful wear in pieces like pendants or earrings. The crystal habit of Heremegevite is often beautifully formed, hexagonal prisms with pyramidal or flat terminations. These well-defined crystals are prized by mineral specimen collectors, sometimes even more so than faceted stones, as they represent the mineral in its natural, undisturbed state. Finding a perfectly terminated, gemmy blue Heremegevite crystal is a pinnacle for many collectors of rare minerals. The geological environments where Heremegevite forms are typically granitic pegmatites, or, as in some Namibian occurrences, in miarolitic cavities within granite. These are environments where unusual concentrations of elements like boron and aluminum can occur, allowing for the slow crystallization of rare mineral species. The specific conditions, temperature, pressure, and chemical composition must be perfectly aligned, making its formation an infrequent geological event. Due to its scarcity, Jeremievite is not a gemstone one would encounter in a typical jewelry store. Its market is primarily within the realm of specialist gem dealers, high-end auction houses, and dedicated mineral collectors. The price per carat for fine, blue Jeremievite can be astronomical, reflecting not only its beauty but its profound rarity, often rivaling or exceeding that of more widely known precious stones. There are no famous named Jeremievite gems in the way there is a Hope diamond, largely because significant large historical pieces simply do not exist. Its fame is more of a quiet, revered status among the cognoscenti of the gem world, a whisper of extreme rarity and subtle beauty. Each known piece is, in its own right, a celebrity within the small circle of those who appreciate such esoteric treasures. The challenge in studying and sourcing Jeremievite is compounded by the often remote and difficult terrains where its host pegmatites are found. Prospecting for it is a highly specialized endeavor, requiring geological knowledge, patience, and a considerable amount of luck. The yields are invariably small, ensuring that Jeremievite will likely always remain one of the rarest and most exclusive gemstones on the planet. Thus, Jeremievite stands as a testament to the Earth's capacity to produce crystalline wonders of exquisite delicacy and profound scarcity. Its subtle blue hues, perfect crystal forms, and the sheer improbability of its existence make it a true holy grail for gem and mineral aficionados. It is a quiet star in the firmament of gemstones, its light seen by few, but cherished deeply by those who understand its remarkable story. Chapter 5. Larimar, the Dolphin Stone of the Caribbean. Our final blue gemstone takes us to the sun-drenched shores of the Caribbean, specifically to the Dominican Republic, the only place on Earth where Larimar is found. This enchanting stone, with its swirling patterns of blues, whites, and sometimes greens, evokes the very essence of tropical waters, a serene and captivating beauty quite unlike any other gem. Its story is one of relatively recent discovery and a deep connection to the sea. Larimar is a rare blue variety of pectolite, a sodium-calcium silicate hydroxide. While pectolite itself is not uncommon, occurring in various locations worldwide, nowhere else does it exhibit the unique volcanic blue coloration seen in the Dominican material. This specific hue is attributed to the substitution of calcium with trace amounts of copper within its crystal structure, a geological quirk confined to a very small mountainous region in the province of Barahona. The discovery of Larimar by the modern world occurred in 1974, although local inhabitants were likely aware of these blue stones found on beaches for generations. Miguel Mendez, a Dominican, and Norman Rilling, a visiting U.S. Peace Corps volunteer, found pieces washed ashore. Mendez combined his daughter's name, Larissa, with the Spanish word for sea mar to create the evocative name Larimar. This poetic name perfectly captures its aquatic allure. The source of Larimar remained a mystery for a short while after its beach discovery, until locals traced the stones up the Bajaruco River, eventually leading them to the Sierra de Bajaruco, where the primary deposits were found in situ within volcanic rocks, specifically andesite. The mining of Larimar is therefore a challenging endeavor, often involving tunneling into the mountainsides in pursuit of these precious blue veins. A truly fascinating tidbit about Larimar is its association with volcanic activity. It formed within cavities and fissures in basaltic lava flows as hot gases pushed mineral-rich solutions upwards. As these solutions cooled, the pectolite crystallized, with the copper imparting its signature blue. This volcanic birth gives Larimar a fiery origin, contrasting beautifully with its cool, watery appearance, a testament to the dynamic forces that shape the Caribbean islands. The patterns within Larimar are one of its most cherished characteristics. They can range from soft, cloud-like wisps of white and blue to more defined web-like or mottled patterns, sometimes resembling sunlight dappling on the surface of the ocean. No two pieces of Larimar are exactly alike, making each gem a unique work of natural art, a miniature abstract painting created by geological processes. Due to its relatively soft nature, around 4.5 to 5 on the Mohs scale, Larimar is most commonly used in jewelry that is less prone to abrasion, such as pendants, earrings, and brooches. It is often cabochon cut to best display its captivating patterns and colors rather than faceted. The stone is immensely popular with tourists visiting the Dominican Republic, and has gained a global following among those who appreciate its unique beauty and calming aesthetic. Beyond its visual appeal, some attribute metaphysical properties to Larimar, believing it to embody the tranquil energies of the sea and sky, promoting peace, clarity and healing, often called the Dolphin Stone or Atlantis Stone. It carries with it a sense of mystique and a connection to ancient maritime legends, adding another layer to its allure for many wearers. The mining is often artisanal, carried out by local Dominicans who have an intimate knowledge of the terrain. The veins of high-quality Larimar can be elusive, and the work is physically demanding. The best quality material, showing deep, vibrant blues with strong contrast, is known as volcanic blue and is the most sought after and valuable. Larimar, therefore, offers us a beautiful conclusion to our journey through rare blue gemstones. It is a child of volcanic fire and Caribbean seas, a stone that captures the idyllic beauty of its island home. Its unique patterns, serene colors and singular origin make it a gem that is both geologically fascinating and aesthetically delightful. A true treasure from the heart of the tropics, reminding us of the beauty that can arise from the Earth's most dynamic processes. Thanks for joining us on this journey through the world of rare blue gemstones, from the abyssal depths where blue diamonds are forged, to the volcanic heart of the Caribbean that gifts us Larimar. We have witnessed the extraordinary conditions and unique chemistries that conspire to create these cerulean marvels. Each stone, a tiny fragment of our planet's vast geological tapestry, tells a story of immense time, pressure, and the serendipitous dance of elements, resulting in hues that captivate our senses and stir our imagination. These 5 gems, the profound blue diamond, the teal enigma of grandidierite, California's fiery benitoite, the crystalline rarity of Jeremejevite, and the oceanic Larimar, represent but a fraction of the Earth's mineralogical wonders. Yet they stand as shining examples of how truly special and diverse the world beneath our feet can be. Their rarity is a reminder of their preciousness, not just in monetary terms, but as irreplaceable components of our planet's natural heritage, each a testament to the slow, patient artistry of nature. We hope this exploration has deepened your appreciation for these incredible natural treasures. The world of gemstones is vast and full of wonder, and there are always more stories waiting to be uncovered, more beauty to be revealed. Don't forget to like, subscribe, and hit the bell icon for more fascinating insights into the world of gemstones. Until next time, may you continue to find beauty in the Earth's hidden masterpieces.